think there was quite a bit of a noise coming from Madhvi, so I just muted her.
Yeah, okay.
So just give me a couple of more minutes, maybe 5 minutes. We'll wait for everyone and let me share the few messages over the group that we are starting the session.
Sure. Most of my colleagues and friends and my teammates are joined actually.
Okay, thanks for that. Hey, hello everyone. I was
Hello.
just putting I was just putting messages to different groups that we were starting. Good to see you all. Uh, yeah, very happy to see that so many people joined before the time. So that's really nice. Me. Yeah, I guess this is better. Let me start sharing the screen as well. Then maybe we can have some casual word. Yeah, so I hope you guys are seeing my screen now. Okay, thanks.
Yeah, Dhaval.
Thanks,
Same
Gaurav.
here.
Thanks, Gopi. Yeah, so I guess maybe we should give a couple of more minutes before we can start. Maybe if I can request you guys to, if you can share your video and, maybe tell me about yourself. Just quickly, what are you guys doing, or anybody would like to share that? How is this session relevant to you guys? I'll be very happy to hear that.
Can I start? Yeah.
Yeah, this is, who is that?
Hussein. So, hi, I'm
Hi,
an AI
Hussein.
engineer in SB. I'm still a student, and I'm doing like medical AI engineer. And when I saw like this deploying zero hallucination AI for healthcare, I thought like that's gonna be something like useful for me, and I will benefit from it that much. So yeah, I'm so super happy to be here.
Okay, and what is your background?
I'm an AI engineer, medical AI engineer. I'm a student still, like, so yeah, I'm in the final year, so the fourth year. And next year is like my big internship, like 6 months, and then I'll be like working. So yeah,
Sure, thanks. Got it,
thanks.
got it. Thank you for sharing that. Anyone else would like to share? So the ask is that if you can uh, share what you do, but what is your expectation of the session, so that when I'm going to the presentation, maybe I could
So
try to answer those.
yeah, can I speak?
Yes, please, Nikhil, right?
Yeah, hi. So I actually am into investments and I run a fund. So actually, I use Claude and other AI models for my research as well as probably to automate a lot of workflows. So result season actually this is currently going on and it gets very busy. So we do a lot of automation with respect to it, brief connecting with Gmail, MCPs, and other stuff. So yeah, I also face a lot of issue with respect to AI hallucinating after a point of time. So I just read the tagline subject and I just
Right.
thought.
Right. Okay, I'll try to add a couple of comments during that section, but this might be a bit off to what you might be expecting, but maybe we can always connect after
Okay.
the
And also
session.
more about if you can just tell how to probably the tokens keep getting consumed, like you might be like since you are into this, so how to probably optimize tokens and make it more efficient. If that you can add, otherwise it's fine. We can connect separately.
Sure, sure. That is not the part of this today's session about the token and optimizing it. But yeah, let's see if I can cover during that time, and otherwise we can always connect.
Sure, sure.
Yeah, thanks, Nikhil, for sharing that.
Yeah.
Yes, anyone else who would like to please share what is the reason and what is the expectation out of the session?
Yes, hello. So I'm myself as well. By educational qualification, I'm a robotics engineer and currently working in AI automation in a product lifecycle management team. So my understanding and expectation, I'm pretty much interested to explore Gen AI based applications and use cases relevant to the healthcare industry, especially surgical intelligence.
Right,
Reason being, actually, my family background is into healthcare sector.
right.
So yeah.
Understood. Got it. So I think that there will be some relevant stuff for you. I have planned to cover 2, 3 sections from Gen AI, from the textual based, visual based, and something toward the mixed reality. So we can. I'm going to cover the breadth. So there will be quite a few input for you. And I guess you have been following my posts and you had requested for the blueprints as well. So I guess yeah, I'm sure that you are very keen about this. Thanks.
A
Thanks.
lot, yes.
Yeah. Yeah, maybe it's time we should start the session, and maybe we can take the questions as and when it arrives. Let me again share my screen. Okay, so I think the whole idea is that why I wanted to have this session is to reach out to people who are working in this domain and who are facing similar problems, that because these are the very niche and upcoming solution that people are waiting for this to happen since so many years. I would like to connect with the set of companies or people who are actually working on this, and especially because Gopi is in the call. We got connected especially because of the few of the articles which I mentioned, which I posted in last month or so, that there are real problems that we would like to fix, but there are quite a few technological and architectural hurdles which are actually stopping us to actually deliver a good healthcare services to the people in need. Can we do something about it, and can we collaborate and make things better? And that's where or at least, yeah, and another reason is I was not able to find a community around this where people are constantly talking about it, where they can go about and reach and say something about this, if they have any questions, or if they can reach out to anybody. So that is also one of the thing. If people do agree, I would like to kind of start some community around this as well, where we can easily reach out to each other. So, sorry, what was that? Yeah, so do you want to ask a question?
I just had a small question. What, like in this entire presentation and this concept, what tech stack are we going to deal with?
Yeah, I'll
Technology
share.
stack.
So
You mentioned a couple of Gen AI. You said
right. So I'll go through the presentation and you'll get to know. I'll try to cover different kind of applications, and within those maybe we'll see if something can be we can go into detail. Otherwise, we can always connect on one-to-one and talk about that. Nurag is saying healthcare has a lot of liability issues. Are you considering that also? Things like yes, yes, Anurag. So I think we will have a bit of a mention and comment about that. Just a second, I guess someone's mic is unmuted. Is that Nikhil?
Yeah, just a second.
Yeah,
It is
thank you.
Nikhil, Mike.
Yeah, thank you guys. Yeah, Anurag. So we'll try to see if we can cover about. I do have a couple of points there, but let's see if whatever I can we can cover based on considering the larger audience. Okay, so I had posted this form itself online, that the list of questions like you are asking. If you already have very well clearly defined questions that you would like me to answer, maybe you can write it down in this form. The ask is, if for whatever reason, if I'm not able to answer towards the end, I can always connect back and get the answers to you. So maybe if you would like, you can scan this and post your question there, and we can always connect again with the detail about exactly what you're looking for. I think I should be able to put this in the chat. Let me quickly do that. Where is that? Okay, I found this link. And there is this chat. Yeah, so here is the form. So please feel free to do so. Brief introduction about myself. So I have done MTech Computer Science from IIT Bombay. I was an applied algorithms student. After that, I briefly worked with NVIDIA for about 3 years, and I was a part of an embedded systems engineer there. I was also working with Arthrex, and at Arthrex, I was leading an AR team where we were supposed to design a surgical guidance solution. This one of the uh, architecture, or one of the things that we will share, is somewhat inspired from what is happening in the market right now, and what are the ideal or set of standard architecture, or things are happening which is actually working these days. And yeah, of course, apart from this, I also tried working on different startups. Two of them miserably failed, and so now this term has become cool. So the startup veteran for 10+ years, it also looks a bit odd. But yeah, I've been struggling, or you can say I've been hustling, not a struggling, hustling with the different kind of startups since last about few years. Anyone would like to connect can again connect with the LinkedIn. This is the QR code, and towards the end I will also share my LinkedIn profile. So cutting the chase, coming directly to the point, what I do now. So I help medtech companies or their team to journey from something is a good idea to it's actually ready for the OR. Right. This is what in nutshell I can summarize that we have something to be done. There is a problem. There is a new technology coming up, and can we use that technology, especially niche technologies like AR, VR, computer vision, AI? Can we get this idea up and running and make it available to the OR? So this is the journey that I'd like to help everyone with. So it's a very vast domain. So today I would like to cover 2-3 points which I felt were relevant. I have been posting about different kind of problem and solutions in on LinkedIn about from past 5 to 6 weeks, and I saw certain traction on some of the uh, articles, and based on that, I thought maybe this 2 or 3 might be a good idea, and it is also going to cover the breadth of different solutions, technical solutions that we can provide. So we'll be focusing on 3 of the things. Cloud-based models are too slow for real-time guidance. So this is a bit of a technical sentence, but the idea is that if we want a solution in the OR and the processing is happening far away, right? The result that we need, especially during the surgery in the OR, might be slower. So this is one of the things that we would like to see and address. How can we do that? Second is off-the-shelf LLMs that we are used to now. Anything we want to check, the amount of time we used to go towards the search engine now are reduced, and directly we are going to the large language models and we are asking our questions. But now off-the-shelf LLMs might be hallucinating, or they might be returning back the response which may not be trusted, and especially in the high stake environment it can be fatal. So we would like to make sure that this kind of applications are really guarded from all this. And then static 2D data creates a cognitive training for the surgeon. So we'll see how adding more things to the OR might actually increase the cognitive load, right? Can we do something about this? Can we do something better, which instead of reducing the load, but also can make the surgery better? So on those lines, we'll try to cover something. So the underlying simpler one sentence information here is that generalist AI is failing in clinical environment. What can we do about this? Can we do something about this? There are, as we said, this theory. First thing that I would like to cover about this, cloud-based model that we talked about. Can we use the technology which can help us with the precision and is also fast, right? There is always this question about doing things with precision, but it can be slower. If you want to do it fast, we may have to compromise certain things, right? So can we somehow design something, architect something which is both? So let's see. I would like to first start with a very simple demos and videos. These are probably something that we might already know, but we will try to build up on top of this towards the end goal, or ideal goal that we should be achieving. So the first is a real-time instrument tracking. This is very simple. Oops, sorry. Is this clickable? Let me confirm. Are you guys seeing my video screen as well, right?
Yes, Dhaval.
Yeah. Thank
Yes,
you.
we can see it.
This is very simple, probably some project work from some student, but I'm just trying to build up on top of this, that if there is a camera which is in the OR and there are instruments which are moving around and we would like to know what is happening with what instrument, there is a way we can easily track that, right? This is a very basic, but underlying assumption is it should be real-time instrument tracking, right? We would like to know what is happening. Now imagine the same thing. So for another, another point, that it's really difficult to get a with demo videos or stuff which can be publicly shown in, especially in the healthcare domain. So I have tried to bring up the videos from here and there, so please bear with that. Let me know if you have questions to understand the concept, that where am I going, so maybe we can stop and try to engage into that. But yeah, so that's the idea, and that's why I have tried to get the videos from which are available in the public domain and making point for our presentation. Similarly, real-time tracking not only of the instrument but also of the things of the anatomy. When the anatomy is open, can we real time track some part of it, maybe some tissue, maybe some bones, maybe some particular part of the body, and can we keep track of those, right? So this is another use case we want to see. A quick example about and how doesn't during the OR in the surgery, let's say in the OR, this is the setup of this is a situation where a surgeon is doing a surgery of uh, liver tumor, right? They are trying to remove a tumor here. Now, typically during the OR, this is a very high cognitive and very sensitive time. If somehow during this kind of surgery, along with the instrument, if we can give them some visual cues which are accurate, precise, and also at the real-time speed, right? Say, for example, given this, I think they are actually explaining it right now, so that's why the video is paused. Just give it a second. Right, so let's say they are trying to remove this part of the tumor, right? Now, while doing that, so during the surgery, the doctor was also explaining, the surgeon was also explaining that they had already given that the chemo for the 4th time, right? And even with that, there were certain symptoms still visible in the patient, and hence they wanted to do the incision and remove certain part of it. Now, if the cut is less, the problem is, it is highly likely that the problem will reoccur. If by mistake, if the cut is a bit more, there is always a loss. We don't ever want to do that. We ever don't want to do the healthy part of the body, right? So can we somehow create a system which not only track the instrument that we saw, but also segment and also track the part of the live part of the area of interest in the surgery, where it can track, which part is a tumor, which part is not, up to which part is safe to and precisely safe to do the cut. Also, imagine a use case where potentially it is also tracking the instrument, where has it reached the instrument, and it is trying to reach towards a wall which is, or part of the tissue which is already thin, might lead to a cut and bleed, which we don't want. Or maybe there is a before the surgery, just they started, and as they are starting to open up the body, the system notices that there is a potential aneurysm is detected, and it has to be correctly handled while doing the surgery. If we can, these are the different kind of use case that we would like to do, which can make a lot of difference during the surgery. Now we know the stake, the type of application that we would like to address. The question that we had asked initially in the different the basically to ask is here is that, can we create a system real time? When we say real time, can this be a sub 20 millisecond delay, with real time, such that the updation is less than 20 millisecond per frame, right? So this is something that can become very, very important. So say, for example, if we are in the OR where surgeon is trying to do this cut, where we are trying to superimpose the area of the tumor, right? And the video feed is going to the cloud, doing some inferences, coming back and superimposing the data on the surgical monitor. Now imagine, for some reason there is a latency, the internet is slow. For some reason, it is well known that even in the hospital the internet may or may not be, there might be a glitch for few seconds, and there is a delay in the overlap, or there is a situation where there is no overlapping of the information. Most likely, if the system is not trusted and available all throughout the time during such high cognitive load and during this serious efforts, most likely surgeon is going to put the solution off because they don't want a distraction. How can we then make sure that these things are actually done right? So if instead of moving everything towards, if we putting anything at all towards the cloud, if we move everything in the OR, if we create a surgical tower where the feed is being processed at the edge in the OR itself, where it contains a high capacity computing power, and all of this is done right there, just right next to the patient, and served directly to the surgical monitor. This can be achieved in less than 20 milliseconds, which makes the mandate for the real-time solution. So how do we do that? This falls more towards architecting it right, rather than having something which is powerful. Once we know this, what are the steps, or what are the kind of hardware and software involved in this which can help us achieve this? So just a quick go through about the architecting this kind of solution is, just imagine that we have certain again assuming one of the applications, let's say for example a laparoscopy surgery, where we have a laparoscope, we have a camera feed coming from there, and this acts as a local edge computing power for us, which will actually do the main computational power computing for us, different kind of whatever the. So here in this case we are considering about the, let's say, soft tissue detection, or cancerous detection, or some kind of maybe in case of orthopedic, maybe we would like to do the registration with the bones, or different kind of fluid detection, or whatever the problem that we are solving. There can be different kind of AI and computer vision filters and solutions that will be executed over the central part. And once we have those things resolved, we overlay the information on top of it, and we simply display those on the monitor here next to it. This can make the entire video processing pipeline from capturing getting the raw, capturing, then pre-processing, then filtering through the AI, and again overlaying with the relevant information for the client, for the surgeons, there and there itself within the and all of this again has to be backed up with the I don't know about different countries, but we have to make sure that the power, not the computational power, but the electric power and all those things, solutions are also be executed. But again, it has to be provisioned at least that those things are all taken care, or we know about the what are the capacity and availability of those. So this was the first part. Second part that we any questions towards this, we would like to cover a couple of more points, a couple of more pillars, and then we are anyway going to open for the questions. But any particular questions for this? I think yes. Asad asked that is it on-prem? Yes, this is the on-premises. That's also called on-prem. Okay, so moving on. So second part is the clinical safety or the zero hallucination part. So I guess I think Anurag mentioned in the comment somewhere, right, about the liabilities. So hallucination are regulatory liabilities, right? And as we are using all this this chat GPT and the LLM models, confident sounding guesswork, we are always getting a solution or a response which is mostly confident, right? And praising and giving us that you are right, these are the things that you should be doing. But this could be a big clinical risk, right? So this in fact, confident sounding guesswork is a clinical risk is one of the comment that I received on in one of the articles that I published last week. And how do we take care of this? We do a zero hallucinating RAG. So that is retrieval augmented generation. The so I'm saving this. Okay. So how can we ensure that the responses that we are getting is of zero hallucination, right? So we don't prompt the AI to know medicine. We architect a semantic index where the clinical truth is mathematically enforced. Now, what does that mean? If I think some of you also already mentioned that you are working with the LLM and you might be aware about something called embeddings, right? That's the crux where this information or the words are converted into a form of mathematical vectors where the meaning is actually very well retained. And instead of hallucination, it actually creates something meaningful and response back, which creates more meaning the way we create the meaning out of words. So, but the problem is, let's take some example. When we say the word bank, right? Typically, based on your context, you might assume about it, correct? This is one of the classical example that it might be a river bank or it might be a money bank, but depending on the context. I guess I think Nikhil mentioned he was working in the fintech, and by default, when someone says bank, we are talking about the money bank over here, right? Now, that's not always the case, right? The generic LLM might not give us the context rightly set up for the healthcare. We have to somehow train that, and we have to make sure that we are using the rightly trained models or rightly trained infrastructure that is designed in such a way that the context is always assumed. Another example is like the words positive and negative, right? Usually you would like to be a negative for medical reports, but when we talk, in a general conversation, we would like to have things more positive than negative, right? So positive, negative, also very simple and commonly used words, but the meaning flips, or the mathematical representation flips. Okay, I think there is a question in Anurag is asking, how does an AI model handle that? I don't really know, or probably present a probabilistic model, which a real MD would still need an MD sign off of the report also. Okay, let me cover this part, and then let's see if we can address that, Anurag. Again, the word stool, right? Typically in a conversion, it's like a chair or a backlash chair, but in case of medical, it's a bowel movement we are referring to, and there are a number of such words like culture, dressing, discharge. These are the words. So how can we make sure? So typically when the words are converted into a mathematical structure, which are called embeddings, there is a meaning associated with those, and those meanings are such a way that when we do a mathematical operation on those, say for example, how many of you are aware about this king, this kind of mathematical vector expression of this words? Anyone aware about those? Right. So somehow this model saves the information, understands the information about what does this word king mean, right? And if we remove the meaning men out of it and add a woman to it, mathematically that vector that we see, king minus man plus woman, somehow it starts pointing towards the word queen. So this language, these words, when they are converted to vector, they are somehow embedding the different kind of meanings which can represent the way we are talking about. Now, what do we want is, we want this kind of meaning particularly being understood in terms of medical vocabulary and not the English general vocabulary, right? That's where the fundamental part of the hallucination starts. If I talk about autology and I say remove ears and add eye, what do you think should be the answer? If you assume that the vector mathematics works well, what do you think should be the answer for this? Anyone, any guess? Yes. So if you're dealing with a department of healthcare which deals with ears, and if we remove ears from it and we add eyes to that, what does that mean? That we are talking about the department which talks about the eyes, which will be ophthalmology, right? So the answer should be ophthalmology in this. And if our core model understands, we are able to create a model architect in such a way that it at core understands this, we are in a much better state than to even make sure that the input that we are giving, the output we are expecting, are on the same lines of medical vocabulary than general English vocabulary. Right. Similarly, we have more examples here as well. I'll quickly show you the expected answers. So these are the different examples which, when we talk, when we see this kind of mathematics with the general language models, which are not trained specifically for the medicine or medical vocabulary, the answers differ significantly compared to if there is a model which we are using, which is trained specifically for the medical domain data. Right? So these are the few of the examples. Of course, it doesn't, regular model fails all the time, or it doesn't, like, it's not like it doesn't work in some of the cases, but I would try to put up few of the question, a few of the points, which is, yeah. So both, you have a question?
So is it kind of NER, like next step to NER, name entity recognition?
Sorry, your voice was not clear.
Name entity recognition, I said. Is it
What?
Named entity recognition.
Names recognition?
entity recognition?
What do you mean by that?
So basically, we try to understand the context and then we map that to particular vector.
Right. Okay. So that, yes, in a way, yes. Name entity registration, right? You mean recognition, right? So
Right.
correct. So this is still a bit more advanced. This was at the yeah, yes. I think that's a correct way to put that. Though I was still thinking from the individual word point of view, single single word and how does it mean independently. But when we start putting this into the RAG, where we want to extract more and more meaningful chunk out of the extraction, this will play a bigger role. But yes, this is mainly about that if this somehow we recognize what does this mean, and this word, when we by default give the context of medical vocabulary, it might mean something else. That's what we want to capture. So recognition not as a general word, but recognition as a medical vocabulary. But yes, that's correct. So now I had a small technical Jupyter notebook for this. I based on the audience, I'm not sure whether we should go through this or not. Let me still just quickly open it and show you the results. I can share this notebook, which will show you how does this work. The underlying, let me see if I have that slide. Okay, I don't have it. So I can quickly go through the result or output of this notebook and show you the difference, where the difference are coming. See, the example that we just showed on the slide was coming from this notebook itself. So say for example, this example that I just showed, right? I hope this is visible now. When we try to do this vector-based calculations, if you can see well over here, right? The regular model was giving this answer, cirrhosis, and it was expected was hepatitis, right? Now, this was failing with the help of general large language models, general embeddings. Now, if we use a specific medical based model embedding models, like, so these are some of the models which are already available. So PubMed Bird is one of the one of those, and I have used that in the notebook. I mean, others can also be used, but I have just kept it for the simplicity. I am using just one for the output for now. And using that, we do get the expected result and the semantic meaning of each of these words together. So all these cases which I represented are much more cleaner and much more successfully being understood compared to the regular embeddings. So if we see even for the regular, so I have plotted the different vocabulary for both the embedding models. If you notice, even for generic words, on the when it tries to assign a vector value to that, it will try to create an average value of the meaning towards the entire vocabulary. Even there, the words like insulin and glucose are close together, but particularly for the medical medpub bird, the glucose, insulin, and hyperglycemia, these are getting placed together. So somehow these are more related. The idea is we should be using an embedding models which cluster the words which are of more meaningful to each other together and in a closer cluster. So though at fundamental level, if we can design a system, or if we can have a embedding models which can do this successfully, makes the subsequent steps much more easier, or highly likely to succeed. So that's the main crux of this. Unfortunately, I have not covered the RAG part on this. For the RAG, let's say we are prompting a question, right? And the language model is not able to get this context so well, considering there is a gap either in the based of the regular embedding and medical embedding. Let's say the difference is of just merely 20%, not even more, right? The understanding of the question will be reduced by 20%. Then let's say we are implementing a RAG to implement a zero hallucination, where we would like to have the context or the chunks that we are extracting from the documents will also be failed by again 20% to get the relevant solution there. And there was one more point. How was this? And the response that will be synthesized will again have a 20% impact on that. Even a simple single chain response will make this degraded by, let's say, 60%, or maybe a cumulative percentage of this, not 60%, but 20% of each time. Say again, not 60%, but maybe up to 54% or so, right? And if we start up implementing a lang chain, or we want to do a chain of such questions when we start implementing something like agentic models or agentic solution, the impact will be compounded. So at the fundamental level, we should be doing this. Second, a quick response to what Anurag has mentioned. Even with this, having a good embedded vocabulary based embedding models, we have to make sure that the response and the confidence we are getting, because with each of the response we always get the confidence score, right? Very easy and quick thing that we can do is, if the confidence of the solution is less than 90% or 85%, we can always put a rail guard that I am not sure about the solution, I really don't know. Or along with that, depending on the use case or the application, we might put some kind of score along with the response, that depending on who the users are, we might want to put a score, or we might want to project in a language that actually says that probably this is 60% correct, but these are the findings that I have. So these are some of the things that we can implement. Sorry, I'm going in the wrong direction, and I would quickly like to cover some of the point on this, and then we will open it for the general questions. And the third part is I wanted to cover was adaptation and interface for different solutions in the OR, right? I'll quickly show one of the demo just to give you the gist about what. So this is the we saw earlier the demo of instrument tracking, right? That where the instrument is in the frame. Now that was done in 2D. Can we somehow track the instrument in 3D? So we are not only tracking their position in the 2D frame, we are somehow understanding the scene where the what objects are, and we are trying to understand the orientation of that object as well. So this is the example of, let's say we have this is the sample application which I had only created with this. That's why I'm able to share this. Once this object is detected, and we can easily track this as well in the 3D structure, 3D environment, right? So That okay, and this is not only done. This is done only once, and as soon as the system restarts, it automatically detects and start tracking it in the real time. So this is done in a real time tracking of the object in the 3D. Yeah, Subodh. Yeah, Subodh, you lost.
No, it's Gopi, I think. Gopi raised the hand.
Okay. Yeah. Okay. Subodh, can you put down the hand so that because I only see your his hand at the top, or maybe I can also do that. Sorry. Yeah, Gopi.
After the pointed, is it a model? Is a CAD model or a reconstructed model? I mean, the spanner, sorry, cutting player model. It is on live. It is a reconstructed, extracted from the point cloud, or I think it is an overlay. I mean, it is a design CAD, right?
Yes. The
CAD
the gray color one that you are seeing here
is
a 3D object created from the CAD model. So the model was converted into an object file or USD file, and then it was displayed on top of it once the orientation and location was located, was registered. Yeah, that answers your question.
Yes.
Okay, so now just a quick point. So this application was running on mobile processor, right? And if we move, imagine now, imagine the situation in the OR where we have to track more things, but with the dedicated GPU and high performance machines, we can easily achieve both the high frame rate and also the precision by a few millimeters. So it is very well possible. This demo is trying to show us, give us a confidence that these things are possible. Now, this was done on a phone. Then with the very high computing power machine just right next to us, we should be able to achieve more. Right? Now, given this, now because this was on a phone and we have to hold the phone to see the solution, right? Where do we really want this to be shown to surgeon? Because surgeons' hands are going to be busy. We really want to add more screens to the surgeon where the cognitive load is already high. So the very obvious solution is, can we somehow make, given that we know about AR and VR and MR, can we somehow make an MR solution, mixed reality based solution for surgeons, where people are allowed to have the free hands, but also augment their world with the precise and important information just rightly available into their cognitive abilities, like either audio or maybe the video itself. Right? So I would like to show again 2 quick videos. Show one more video where it will give us the idea that how does it look through the eyes of it. Now, this is about a spine surgery, and the surgeon is explaining about all these things which I just mentioned, that the information is visible now right directly into the eye and exactly on top of the relevant part of the anatomy. Now they are supposed to do the surgery where the precision is very high, like a precision of a needle size. So yeah, so this is the view, right? So while doing the surgery, if on top of the anatomy itself of the body, we are seeing that the X-ray scan of the patient, that this is the part where you would probably see this particular vertebra, this particular bone or object or tissue that we would like to cut upright, and the scans and how far those are, how much inside you want supposed to go or how much inside you already are, and then you can do, because in a minimal invasive surgeries we don't have a direct view, right? So there are different challenges, different issues for different kind of surgeries. Now this is actually showing. There is also another, I forgot to mention in the presentation, but there are surgeries where we have to keep doing the X-rays or fast light scans of the patient to know the latest status, like every minute or so, to actually guess the situation of the patient inside. With the help of MR, we might be able to reduce that as well. Right? So these are the different applications that can be really helpful. So using those, what are the main benefits? So we reduce the cognitive load. Instead of looking around everywhere, everything is now right next to. Right now, I don't have to mathematically worry about different things. It is showing that much length, and this is showing that we have cut up to this much part. All of those is combined and directly available to on the place where is most relevant, right? We reduce the head movement so that the surgeon is more focused, and we can also increase the surgeon focus on the patient anatomy, more time spent on the body rather than moving things around. So we are also able to increase the total information, and again, as I mentioned, directly available in the field of view. So this is how do we architect this? So this is the a high level architecture about designing this kind of solution. I would like to quickly give you an idea about the different parts. So first of all, I think Gopi already asked that question about that plucker, that was that a model, a CAD model or not? So when we scan the bones, say for example, we're taking an example of a bone or orthopedic surgery, we have the data in the STL file, right? We convert that data into, we take that and we process that. Now, because we know this is the 3D structure of the patient. Now, this is again an important part, important because all this surgery are actually for the patient and patient specific. I cannot have a generic bone representing the bone of anybody. There should be a good registration between the 3D scan data and the actual patient. So when we know the 3D scan data, it has to be converted, and the system should understand the size, scale, and orientation of that. And once the surgeon looks at it, we should be able to do a registration for that, right? So we know the data, we know the patient scan. Second is somehow we understand the feed from the device. If the camera is capturing something, there can be different kind of cameras. It can be RGB based, it can be time of flight, right? It can be distance, and different kind of information we have. Can we somehow track the scene? Can we somehow isolate where exactly could be the object or the bone that we are trying to track? So once we have this information, we extract maybe certain features, we extract something, cloud points, and we try to do the matching. There are different algorithms available to that. Yes, Aslam, you want to ask a question? Let me just quickly go through this two at the very abstract level, then maybe you can ask. And
Yeah.
once we have this set of cloud points, one from the actual data, one from the real scene view, maybe we can use a different algorithm to match those, like ICP. And once we have the orientation detected, once we have the system in place that this is the expected location, right? We again, with the help of different information like depth, we can do the occlusion. We can again apply certain kind of texture mapping that we know that, let's say it is a bone, then it will be different kind of texture. If it is a tissue, we apply different kind of tissue, and we basically clean it up. We give it a proper sync and shaders, and ultimately superimpose and overlay that information on top of the actual video feed and send it to the headset. Now, again, there are different kind of headset available. This is the previous video which I showed was of HoloLens, but it can be Vision Pro, but it has a different way. It is not a transparent. It's actually a video feed. HoloLens was a transparent. So both of these has a different use case or a different way to tackle it. But this, at a gist, towards the end, the surgeon sees the overlay on top of it, that this is where they are supposed to do what they are supposed to do. Yes, yes, Aslam.
As you said, it's a bone surgery. For example, the person has a flat foot with the extra bone on the ankle.
Flat foot.
Flat foot, extra bone on the ankle.
Okay.
So how the data will differ? How it will show? It will show the normal foot with the ankle data, or it will show the two bones with the ankle data?
How does the STL data will normal? What do you mean by that? So here the expectation is this STL data will be the actual scan of the patient. So it will be the foot with the flat foot and the extra bone at the ankle. So this STL data will be that. It will be a patient specific. Otherwise, we can't do the registration between this and the real 3D point.
Okay. And one more thing, if you're going for the heart surgery,
Heart surgery.
if a patient has a heart attack in the extreme level, there is a cold LVAD device that is left ventricle assist device. So if you are going through the device surgery, it will give the data exactly where to cut and how to insert the device to the heart. Are we
Right.
going through?
Right. So right. So this all of these different surgeries will have a their own specific solutioning. So this is a generic structure for bones. In case of heart, now the thing is, I actually don't know about the details about how the heart surgery work, but assuming it's a soft tissue, it might stretch and it might also change location. In case of bone, it can only move, but the structure is going to be stable, right? But in case of heart or soft tissues, the tissues and the organs might even expand, might even stretch. Those kind of things can also happen, right? So now assuming that those nuances the solution is trying to target are aware about it. And here, when we instead of do at level 4, when we do occlusion curling, sorry, not there. At this point, when we do real-time point cloud matching, we may have to do some texture matching, and we have to find the stretching part as well. And then on top of it, we have to somehow track the movements and do the real-time movements of the 3D structure as well. This will help us follow this will help the surgeon to show exactly how to do the procedure. Now again, on top of that, there might be instrument where the surgery is done actually on a static heart and it is translated somewhere else. So there are different kind of solutions being available. I hope I was able to answer to some extent.
Yeah.
Was it making any sense, or that was like clear as mud, like not clear at all?
No, it has a point, but I have shared a video just looking to it.
Okay.
That's my question. How this device will
Sure. Let's take that towards the end. I think we are already running out of some time. Gopi, you want to go ahead? You want to ask something?
Yeah. I mean, for this, I mean, you are using any of the existing frameworks or this ICMP algorithm, even for the you shown me on the phone sample also.
Yeah.
For that, you are using any existing frameworks, or else you are implemented this is a from the scratch solutions.
So the first demo that I showed about that plucker, it was done from the scratch.
Okay.
So it was that the iPhone has a LiDAR sensor which also captures the depth, right? So it was able to capture a much better point cloud compared to let's say you want to capture a point cloud from a regular RGB files or RGB images. Now, because of that, the STL file and this comparison is relevantly easier that we can achieve. Now,
I think you are utilizing the AR core or AR kit.
AR kit, because it's an iPhone, no, so it has to be AR kit. AR core.
For Android.
It works only on Android. So yeah, so that's what it is. Any other question, or maybe we can quickly try to cover the rest of the points. Okay, so now a quick, I'll try to a bit fast now. So the key takeaway is the registration is not an event, it's in a continuous state. So now, because this is not a one-time thing, once we have it, we have to keep following it. For the dynamic OR, so this is again this particular video which I showed, where the the bone is actually static and very much stable with respect to the environment, right? The environment was stable and this was also stable. So once we, if you notice in this video, once we register, we are able to track it very easily. But in case of dynamic OR, the registration is not a single time event, it's a continuous process that we have to keep doing. Same is the case for the soft tissues as well. Once the tissue stretches or changes the size and position, we have to keep tracking in the real time in all the time, right? We solve the z-axis drift by occlusion by fusing the SLAM, right? SLAM is again something that we create the meaning of the environment. We are not, so OR is a very happening space, right? Things keep moving. The instruments, the surgeons, the people who are helping to the surgeon, all the other doctors, maybe even the device and the towers which are available are also moving around. So it's not a one-time thing. We have to keep monitoring and keep understanding the scene in real time, correct? Right, and then we have to offload this non-rigid deformation. So when we encounter these additional problems, right, we start stacking up those systems. Again, a powerful GPU-based system in edge on premises on top of the other machines. So let's say we have a dedicated machines available to solve each of these problems. So when we have this architecture, right, this might be, occlusion and non-rigid deformation might be coming from two different machines. Once we have this data, will be merged together and overlaid and before sending it to the server, before sending it to the headset, right? So we have to, this is required in order to achieve this sub 20 millisecond latency, right? So now a very quick thing. This is the ideal state that we want to reach, right? This is again a static, a dynamic, something that ideal state we want to reach, but it's a long journey, right? It is not possible to reach there overnight. Then, so what should we do, right? There are different challenges that we must address before reaching there. Is first of all validation. When we are trying to make some solution, we would like to validate whether we are going into correct direction or not. Second, there is always a revenue or the ROI question. If I'm going to make this, who is going to fund my research? Who is going to fund my the product while I'm making it? Accessibility. We don't want to wait till the entire product is made to reach out to somebody. If there are ways we can create into some smaller products which can be helpful, which can be accessible to people to make their life better, right? Can we somehow make the access to our application and get our earlier adopters of our product so that they are already well versed till the time we actually make this entire solution. So these are some of the points help us think to address, or define our journey. How can we reach to this surgical AR level, right? There are a lot of videos, and I think we don't want to go through all of those. But let's say there are 3 intermediate steps I can very easily see that we can go through to reach that level, which can also give us the benefit of these 4 points. One is simple 3D visualization, right? This is not highlighted. I forgot the naming of this. Which one is that? Right? So this is very important. Now imagine the questions that you guys were asking, Aslam was asking about, bone. Ankle has a, extra bone. Now imagine you could show me a 5-second video of that. That can communicate much better than just trying to explain it over the reports or trying to explain it over the words. So 3D visualization is the very first step that we can achieve. We can have a simple tool which can simply read the this STL files or the DICOM files that we have and display it, which can make things much easier for people to talk, right? If you talk about this particular video, this is a very generic video, right? But it is not a patient specific. We can take those files and make it patient specific, and that can also help us make it a pre-op planning. Now, even if we don't have the surgical system to actually do the, which is available during the operation, but can we somehow create tools which can help people to make the surgery, which can help make the plan for the surgery? Say, for example, again, let's take the example of what Aslam shared, that there is a patient with a extra bone at the ankle and which needs to be addressed, but because with the age it is now, there is a friction and there is a lot of pain. So what is the corrective measure? How much should we remove it? How much should we correct it? How much should we rub it? From where, which angle we should insert, or where should we open it, right? There are different questions available. There are different answers that we need to be planned for. And this, once we have, let's say, which one should I take? Maybe this one. Yeah, so instead of that, this is a, so this is a demo from yeah, so this is the pelvic region of the body where the scan is already available, and they are trying to see that there is this red part is a pathogen, and they would like to operate over here. They are visualizing it in different capacity. They are trying to plan it out. They should be able to do certain things in this part of the body, or this part of the organ. They should be reaching out from this part. Insertion should be done on this part. How far is the pathology, and depending on that we can do the planning, right? Again, this might also give you the same idea. Yeah, so this is for the orthopedics. Again, this is how the implant will look like once it is done. Then we submit it, and we see that this is the final plan. Other people can review it, they can visualize it, maintain the information over the different kind of CRMs. This is how this can be. With all the degrees and details, a planning can be done. What is the con of that? Even though we have this, there is no way to know if the actual plan was actually implemented during the surgery or not. And the third thing that can help us is we can make a surgical training and simulations, right? Along with the 3D scan, if we can help them do the execution of the surgery, or first it can help you show how the surgery can be done, then it gives you hint and help you execute. This is the step, these are the steps you are supposed to do the surgery. The surgeon can visualize this. And the third is, in the simulation itself, there is open-ended surgery that you are supposed to execute on the 3D digital data. What are the advantage? This can be done on the actual patient data. It can be of the real size, the scale. You can feel like you are at the OR, there is a patient, what are the systems are. This can be done remotely, as there are different students. I guess we have one over in the current session as well, that we would like all the students to go through same surgery rather than everyone sharing and someone surgeon is just showing it. This can help do the solve the logistic problem. It can reduce the cost, and we can do a lot of training faster with this kind of technology. And of course, this is safe because you can repeat it until you actually achieve it, right? The desired learnings. There are again different demos for this. Maybe I think we are running out of time. Are you guys okay to extend this for 10 more minutes? Okay.
Fine, Dhaval, or else
Yeah, because I think I put a lot of information, even I was feeling that, but yeah, thank you guys for understanding. If anyone would like to leave earlier, they have any questions, please raise their hand or let me know. I'll try to answer that and then I can continue the rest of the points. Yeah, but I would quickly like to show this then. Right. So this is a VR simulator this is the trainee. Trainee is looking into the VR headset. They have different kind of devices. The operating room is stored, is up. The trainee, supposedly surgeon, is able to access the the operation theater is set with all the device and everything, and it can also track what kind of steps are being executed after what, and there is a monitor just like a operation theater, right? So you can actually execute the simulation on the actual patient data. And yeah, in this case, imagine if it is a ankle, we have that actual 3D scan of the actual patient, and we can have the surgeons practice on that itself rather than just a generic ankle, right? And some of the cons, maybe I can show you one more video, should give you a better idea. Right, again, there is this, you are supposed to execute patient data is there, the steps are there, you are executing the some of the steps that you are supposed to do before that, clinical procedures, and then you put them under anesthesia, you check it out, few things, do the IV. Yeah, so this is another simulation platform, and this is another knee surgery. So the doctor is trying to show, this is again a room where we have the entire OR set up. Then with the help of technology, it will also guide you. It can also guide that you are supposed to do what. So say, for example, you are supposed to get the leg up by this much position, then the marking guidelines will be shown where to do the cut, right? You're supposed to take this instrument, it is supposed to be at this level, and then you are supposed to do the cuts over here. So this again become a very helpful tool, right? So architecting this real-time surgical simulation from pre-op data, that is the actual patient data. What are the overall benefits that we just saw? That we can practice on the actual surgery with zero risk. Training becomes much more visual, right? Support and assistant can be from the other side of the world. That somebody is at the, let's say, the surgeon, a specialist is available only from India or US, and surgery is supposed to be somewhere in Europe. All this can be also very well supported with this simulation and with this kind of tools. We can reduce the clinical learning curve, right? And this, again, all of this, each of the steps becomes a path towards the surgical AR system, right? Yes, Anurag. Anurag, are you speaking? You are on mute?
Sorry. For a lot of these systems, you cannot really do this because the MDs need to be licensed in their particular, I guess, countries or whatever it is, and that can create a problem for what you're saying, working on the other side of the world. Just a side note.
Right. So I guess for the training part, it's all fully restricted. Anurag? Because okay, so let me give you a bit of a. So I was working.
No, I mean, I've encountered this problem, and they won't let you export the data from one country to another.
Yes.
And you can't really get it legally. And I know the ACR has got some, de-identified data sets you can use, but typically for real, world scenario, you don't get the data very easily.
Right. You don't get the data. You are not supposed to store it outside of their country land. So streaming is something that is allowed. And for the simulation, I think here there is one company here in Pune for which we were exploring the potential project, where they had another subsidiary in Europe. I think it was in Switzerland, Geneva, and they wanted to create a simulating tool where people from different countries should be able to see and learn how we can operate. Now, at least if we are not using the patient's data, at least the training part can be executed, right? We can have the proof of validation for our different tools, and we can they can easily share it across. It works like more as a real-time operating teaching sessions. Now, even with the proprietary data, with the HIPAA and GDPR and different kind of compliances, the streaming is, I think, okay. There are provisions that the data is of patient is actually on the cloud server of that country.
And totally de-identified typically. You want to make sure it's totally de-identified if you're moving from one country to another.
Yes. It has to be de-identified, and there are a lot of restrictions. But yeah, there is a way something can be done about this. And of course, this compliances can change anytime, and we have to be very cautious about that. And thank you for pointing that out. Yeah. So as Anurag was saying, and this system does come up with a lot of compliances, and which is actually the need. That there are a lot of genuine reason why they should be kept private. Right. So now, given all of this, there are ways that even though we mentioned that this is a long journey and towards the end we want to have a surgical AR, but is there something better in the future? We can see that is possible. I would like to share something that what can be achieved in the future. But yeah, I guess I should also mention about this part. How can we quickly achieve this? How can we achieve this kind of solution? This is the architecture for that. We get the data, we create our 3D reconstruction pipeline, get the put those into the 3D engine tools like Unity, Unreal. Again, the compliant based edge cloud server where we are storing the data. We have to make sure it is there, and then we display it on the headset devices or on the monitor based on the application. There are a lot of in-between details that we can cover in detail, but because of the running of time, let me just skip this for now. And the future is one of the ideal ways that can we somehow move from a segregated different tool to something which is like totally integrated all together, and can we create something like interactive visual intelligence ecosystem which can help as a real assistance, right? Can we, while doing the surgery, we ask a question like to the system, then what is the distance to the artery? Now, that's a very vague and generic question, but assuming that the entire context is being understood, right? Where we see that we know, or the system knows, the background about this kind of surgeries, has the understanding of the patient's data, has the context or more maybe the reports, and has created a semantic meaning out of this. The first thing that we saw initially. Second is whatever different kind of scans that we have of the patient, the current live scene building, or what's currently happening about the different kind of instrument in the OR. Where are those? Who are the people involved around in the OR? And also a spatial understanding of reconstructing the entire OR. In the manufacturing field, they do call it digital twin of the factories, like replicating the entire thing. Can we somehow track different objects, people, and try to create a special scene mentally that we as a human we typically do? Can we do that in a tools? And all of these things together, again, the way we do it, right? We are seeing something, we are also hearing something, and together we are trying to create a meaning which is useful, combining both of those, not just independently hearing and independently viewing something. Can all of this be combined together? Let's call it a digital nervous system, not our nervous system, but a digital form of it, and then which can become an assistant to the surgeon. So now, given this situation, when the system asks what is the distance to the artery, can system respond back with the, the distance to the artery is 3 millimeter, 2.5 millimeter, 3 millimeter, which is close or which is lesser than what we should be. We should, get the scalpel back, something like that. So this is something is if we can achieve this much. Yeah, Gopi, you have a question?
Yeah, for this system, are you implemented any of this application or?
No, I have not actually. The only thing which I have done personally is something use something called VLMs, visual language models, where some part of this from the 2D frames or the videos we can infer, and we can talk with the along with the text. We can also talk with the images.
Okay. Do you have any samples for this? Or else a sample video, demo videos for this, especially like for the surgery or else medical healthcare applications?
No, I don't have a demo
Okay.
working for the healthcare. I do have a one Jupyter notebook working for some other application. So I'll just to give you a gist. It was Google Gemini's VLM multimodal system, where you send the data, your query along with the picture, and it will give you answer, right?
Google
You can have
MedTech.
that is very well easily available now, but to implement that on edge with our own custom model is a bit something that a challenge that I would like to work on. Yes, I have not worked on till now.
Okay. Or else, did you saw any of the applications? Maybe you don't have any. Did you saw anywhere this system was implemented?
No, not really.
Okay. Because I saw that I just started working, understand the spatial LM actually.
Okay.
Yeah. So that's why I have a curiosity, because it is in a recently released, right?
No, I am not aware about till
Okay.
what is the status of that.
Okay. Okay.
Even the surgical AR system, right? I don't know how many of those are actually approved and they are allowed in the OR, because it also goes through a very long journey.
Okay.
If I give you a very brief, that whatever this architecture system that we just discussed will be prototyped using easier devices, maybe mobile devices or simpler devices. Then it will be executed on the 3D printed material, then maybe on the cadaver, and all these things goes right over the years with the publication and approval and with the evidences. It has to be proposed to the FDA, and FDA approves for a clinical trial within the OR. Then it becomes a mainstream product. So it's a very long journey, even for a surgical AR. So reaching it to this state where we can use LLMs, vision, spatial understanding, and everything together, and giving it to some higher intelligence AI to do all of this. This is something definitely we desire to, and I'm sure the way we as in now Homo sapiens are making a progress in next 50 years or somewhere, this is going to happen. There is no escape. But yeah, right now I don't know actually.
For the spatial LLM and multimodal LLM, you just mentioned that Google MedTech. Okay, as I know that it is crossed, as per my knowledge, 60% of accuracy. After that, I don't know that the status. You have any idea, Google MedTech? Because we can integrate with these kind of applications like Google MedTech, right?
But 60% of accuracy on what? See, that was the initial first question I was trying to address, that the embeddings, when we say the word bank, right? When we say the word stool, it means something, right? There are certain benchmark when they say 60% accuracy. Is this for the medical domain? Is this for the healthcare domain? There will be different benchmarks, right? So I am actually not aware. I'm just trying to counter the question so that all of us think about it. But the point is 60% accuracy with what kind of data, with what kind of application, with what kind of target audience? Is there a serious fatality issue question in the question involved in this, whatever we are trying to do? How much accuracy is okay? Because see, if I remember, imagine autonomous driving cars. I don't know how many countries actually still approve it. If I remember correctly, the technology was there since last 8-9 years, and they need more evidence and a lot of things. Certain countries has, but how about a country like ours, right? There are different laws. We have to see what things approved by whom. A lot of probably some political issues also. I don't know. Yeah, but we have to see in the context of what we want to address.
Okay, so still this is in R&D stage only. I mean, if we, or suppose spatial LLMs are available and mixed reality applications are available. Using this, if you made any applications, I think we can't get still FDA licenses, isn't it?
Sorry, personally, I have not actually worked on that. So I might not be the right person, but we can always connect Gopi later and we can discuss about this.
We'll do that.
But, yeah, let's do that.
Okay.
Yeah, thanks Gopi for that. And yeah, so there were a few questions. I guess maybe we can skip this questions that I had put it down. And if there are specific questions that you guys have, maybe we can address that first.
What's next then after this?
What next after this? All understanding digital nervous system? I don't know. This is I can't think about maybe a generic universal nervous system. I don't know. So that's a big thing. You want to reach till surgical AR level. I think that will be quite a bit of an achievement for different domain and different applications. Yeah. Any other question?
So how would this work when coupled with surgical robotic systems?
From the technical point of view, I can share my imagination, but from the actual surgeon point of view, I don't know about how does that surgeon in the community thinks about it. But the one thing is clear for sure that we are not at the stage even to imagine to give full control to the surgery. I don't know. I think at least that's what my understanding is. So there will be a robotic surgery. A lot of things can be automated, but the underlying system, depending on the different applications. Are you particularly thinking about any particular surgery for when you mentioned about this question?
See now, now there is actually why I asked this because one of my friends, he is into AR VR extended reality research in UK. So he was telling me that there is something that is coming up, which is in research in the UK that is related to teleoperations. So so that's again a totally different system compared to what you showed right now, right? And yours is again different. But rather than rebuilding things from scratch, why not merge this with the existing systems to upgrade or maybe improvise the current systems? Actually, I asked in the chat also, like, are there any research papers that have stated potential challenges or gaps that we are building on top of? Like, what is the backing behind your architecture diagrams that you showed? I wanted to understand because I didn't see any references,
right.
Research paper references, everything.
Right. That's a good question. So there are two things. So when you say teleops, you mean that the robotic arms or some kind of hardware is at one place and it has been controlled by a surgeon sitting far, and he is operating certain part of the it is operating or executing
Correct.
the
Yes.
surgery, and the surgery is happening there, right? And
Yes. Yes.
your question is that can this be automated rather than surgeons doing it? Can this be automated? I think some part
No.
of
No. No. So,
that.
no. My question is, no. Your system, what you showed right now, how can it cooperatively work with the existing system that is there as an add-on or as an improvement or an enhancement, rather than just a different system altogether?
Right. So this is not a separate system. So all of these are in existing system, which is already available in some or the other form right now. So either in the surgery or even for the pre-surgery or planning or just for the visualization, all these are different kind of components and tools which are already there. A lot of people are already using it. There are different products already available in the market. This entire one architecture that I showed was based on the experience that I have worked with different companies. Those are not published. At least I was not part of the publication, so I cannot claim that. I have worked with the companies who have published this. I can share the reference if you want after the call. I think probably it was from with the
Sure.
along with
Sure.
the John Hopkins University, where this entire flow was achieved, where we have the data, where we received it, we pre-process, make the pipeline, make it available onto the 3D visualizing tool, clean it up, make it trackable into the head-mounted devices, and then make it visibly available to the surgeon. So all of those, along with the accuracies as well. So I think one of the things that was done was the accuracy of, let's say, drilling was at less than 2 millimeters and less than 2 degrees, something on those lines, which is considered to be a golden standard for surgeons.
You have a paper down there?
Got it. Got it. Noted. Noted. Thanks.
Yeah, so just a quick point that I would like to mention that so I am opening myself up for connecting with a couple of companies who are working in this domain, and I would like to see if there is I can somehow help. These are the two capacity that typically I do engage with. Either I work as a fractional architect engagement, or I do help as a kind of custom corporate trainer, where I mean these are the terms that I'm just using, but basically help the team to make their engineering team capable enough or fast on a fast track to design or develop this kind of solutions. You can scan this to, if you are interested, I would request you to scan this and fill out the form so that I can know that these are your interests and these are something that we can engage with. I can also share the link in the chat. Yeah, I think that's it. Based on some of the other traction on the articles that I have been publishing, I think I might be doing a second session, maybe a bit more elaborated, or maybe it was specific, maybe towards the second week of June somewhere. These are the two things that are getting traction, as I think you here also, you guys also asked me a few of the questions on this. So this might be the topic that I might want to cover next. I would also like to have a feedback about this entire session and what things can be done. What is your take on this entire thing? So let me write feedback and share this, and the previous form as well. as a partnership I have shared. Yes, so just to quickly summarize that from this particular presentation, we saw three things, right? That if the solution in the OR, we are dealing with the issues like speed, or there is a latency issue, we should be architected in such a way that everything should be designed at the edge. Everything should be executed at the edge. It can be either, we saw the example of mobile device, right? Doing stuff very well with the help of edge towers, which we can achieve much better latency. Second is the safety. Maybe today also there were a couple of questions on the rack. So apart from embeddings, maybe a detailed things about the rack I can try to cover next time, where the hallucination or maybe I can take a technical demo as well. But yeah, the safety part is, we can reduce the risk of hallucination with different kind of architecting decisions that we should take at the beginning of developing our tools or applications. And the adoption of spatial AI, right? The HoloLens. This is the third thing that we covered. And the journey towards how do we reach that, making intermediate tools which are actually been already being proven and validated, and ultimately we can reach towards a surgical AR systems. So yeah, that's it from my side for today. Anything else, I would be more than happy to connect with any of you. Let me share my LinkedIn profile as well on the comment. And that will be it from my side. Yeah, I just shared my profile as well. Yes, so the session is officially over. I am still here for some time. If anybody wants to engage or talk more, yeah, I'm available.
Dhaval, you mentioned that hallucination. If you suggested that, can you please go through the previous slide? Yeah. If it is the zero hallucination, that means it is lead to, 1 second. It is lead to overfitting also, right?
Overfitting of, in what sense? Hallucination, are you talking in terms of we have a set of documents and we would like to get the answers only from those documents, right? Is that right, the application? So what do you mean by overfitting in that case?
Right. If it is in a false positive also, okay. If you try and generally we do the bias, okay, and we try to reduce the zero hallucination, okay. If we bias means generally why we add biases in a different areas in a different purpose. Okay, if it is if we add to avoid zero hallucination, okay, so there is a chance that it can recognize if it is a false positive also, like if you consider there is a cancer X-ray and non-cancerous X-ray, but some of the area we try to add the biases, bias for the to avoid the hallucination, right? So same way, if you try to add that zero hallucination, that means there is a chance of a false positive also, right?
Okay, so are you trying to say that even if there is information, whether positive or negative, if there is information and if it is saying that it doesn't know, say for example, let's say that the tumor case or a simple text-based solution, where the answer is actually there and it is showing that we don't know, other systems is I don't know.
No, a little bit. If it is sometimes we trained for suppose information, consider there is a new, maybe it is not a cancerous, but we are trained whatever the available data. Okay, based on our, we are expecting that there is a non-cancerous image also there, but we try to recognize whether this is a cancerous or not. Okay, if you do that, I mean, I'm asking my question. Okay, this is my curiosity. How this it will be if we fully trained for the zero hallucination. How we try to avoid this? That means if it is a non-cancerous image also, it will try to recognize as a cancerous. Okay, based on we don't have any sufficient data, but we are instructed that zero hallucination, then there is a chance of false positive recognition, because when I'm learned this is I was learned this thing. Okay, so I'm not understand how this was I mean achieved actually.
So when we say hallucination, so hallucination is something AI is producing something which is actually not there. That's what my understanding is.
Yes, that was
correct. So let's
yes.
say in case of cancer you're talking about, right? There is a image. You are saying it's a data of multiple people, I'm assuming, or a single patient. Different images. Some has the cancerous part. Some of the images don't have the cancerous part. Correct. And then you are saying
yes,
that, sorry, yeah. And then given this situation, what is the question now? Where do you see the hallucination?
Yeah, we given a trained data set. Okay, in that for suppose non-cancerous or else non-cancerous cyst or something is there. Okay, but we are not supplying. This is in the training data set. Okay, so when it is comes to the real time to recognize whether it is a cancerous or not. Okay, I mean generally in the trained data set we will supply the we don't do the zero hallucination actually, as per my knowledge. Maybe I'm wrong. Okay, then when we try to recognize on the real time, okay, if it is, we make sure that zero hallucination, but we not supplied the trained data. Then we in a detection time we are expecting whether it is a wound is a, I mean cyst is a whether it is a cancer or not. Okay, so this is a question. Okay, we are not trained data, but we are trying to detecting that. Okay, and we mentioned that zero hallucination. Okay, that means in a trained data set we restricting that zero hallucination. Okay, so that means it is there is a chance that it is an overfitting, and it is if it is the non-cancerous also, there is a chance that it will detect as a cancerous. Okay, I think I was explained clear. To understand?
I'm a bit confused.
Okay, no problem. Then we'll talk in the offline then.
Okay. Yeah, that will be actually better, because I am somehow not able to exactly. Sorry about that.
Okay.
Yeah. Anyone else? Any other questions? Okay, guys. Thank you so much, everyone. Thank you so much for joining, and yeah, thank you for giving me this opportunity to share everything.
Thank you, Dhaval. I literally a lot of information from you actually. Earlier I don't know a lot of things, critical things actually. Yeah. Thank you for your time, Dhaval.
Let's get in touch.
We'll
thank
touch
you
it.
so much.
Yeah.
Thank you, Asad. Thank you, guys. Bye-bye. Thank you. Thank you.
Okay. Dhaval, I'm dropping off.
Yes, please.
Okay.
I'm just waiting for everyone to
let us know that when it is the next schedule. Anyways, we'll fill the feedback form and we'll let you know that what we are expecting. I think in the next session we can go with a little bit deeper. Okay.
Yes.
Yeah.
If you want, we can do the technical. This was
Sure.
more from a non-technical point of view.
I understand.
Okay. Thank you, Gopi.
Bye, Dhaval. Yeah.
Bye.